I forgot to push recording, so I'm gonna back up. Start over. All right, in this course, this is the outline for the course today. And we'll run a couple of jobs and it won't take the entire 2.5 hours. So we'll have plenty of time for questions along the way. So first we're gonna log into ACES. You can go to our main website, hprc.tamu.edu, and then click portal, mouse over portal actually, and then select ACES. So from our portal, hprc.tamu.edu, ACES portal. And that'll open in a new tab. And then you can see this is our on-demand page. If you haven't logged in for the first time, you'll have to go through the two-factor authentication. So you'll see a screen like this, and then you'll need to select however you registered with Access, either using the Access CI ID or if you registered through your institution. So we'll give everyone just a few minutes to log in if you haven't already, and then if you will, just raise your hand in Zoom and then let us know if you've already logged in, so we can get everyone logged in. If you have any questions getting logged in or have any problems, let us know also. So there's a question on chat, will the recording be available? Yes, we're recording it, and then we'll do some processing to clean up some of the pauses, and we have to add captioning, so that usually takes a few weeks. We do have some available in our YouTube page. From our main, let me come back to the slides. From our main web page, you can see we have a link to the YouTube, and from there you can go search a lot of recordings we have. There's actually one new thing in this presentation that's not in the older presentation. So this will be a more up-to-date one, at least for AlphaFold. AlphaFold 2. All right, I see one hand raised. Does anyone need any help getting logged on? We usually have at least one person that failure to link account to name or something like that. You'll need to log on to run these. Of course, you can run it at a later time watching the video, and AlphaFold 2 does not require to fill out the Google form. You can run that, but to run AlphaFold 3, you will need to get the models parameters file. So that will be the Google form that I emailed out, and from that you can save it to your Scratch directory, and you don't have to unzip it, you can leave it compressed. Okay, so we'll be working on the command line. So to access the command line, just mouse over clusters, and then you'll see the ACES shell access. So you got to click cluster, ACES shell access. And then you'll log in. You'll see we've got our message of the day. We'll be using AlphaFold 2 and AlphaFold 3 today. You'll see the message of the day. We've got links to our documentation. And then we've got some messages here, reminders that the login nodes are for temporary testing. For computational jobs, you'll want to submit it to the Slurm scheduler to run it on a compute node. We do have a limit of 8 cores. You are able to test software on the login node. Just be aware that any process that reaches 60 minutes will be automatically stopped. So you can see you have quotas. Keep track of how many files you have in your Scratch or in your home directory. And anytime you can type in show quota to see those again. All right. AlphaFold history. Back in 2018, AlphaFold 1 placed first at this CASP 13 event. Then AlphaFold 2 came out in 2020. And that's when we got a lot of requests to get AlphaFold 2 installed. Actually, we did get requests back when AlphaFold 1 was installed. And then AlphaFold 2 was installed, or it came out. There was a little confusion because really it was the same code repository. The only difference was AlphaFold 2 had multimer support. And then there's the publications, and then 2024 AlphaFold 3 came out, and the only way to run it at that point was using the AlphaFold server, and there were some limitations for academic researchers. Luckily now, code's available on GitHub. The code is available, but you still have to fill out that Google form and agree to their terms of service in order to download the model parameters file. And that was the code was available in late 2024, and then early this year we got AlphaFold 3 running on ACES. We actually have AlphaFold 3 on all of our clusters. All right, let's look at what AlphaFold uses as far as resources. AlphaFold 2 and 3 can only utilize one GPU. There's also, at least these are the numbers I found for AlphaFold 2. They may apply to AlphaFold 3 or not. I haven't seen for AlphaFold 3. But for AlphaFold 2, the minimum amino acid length is 16. The maximum length depends on the database, 2700 for proteomes from SwissProt, 1280 for all other UniProt proteins. When running AlphaFold 2, 90% of the processing is done on CPU, and the way they designed AlphaFold 2 was that there's 4 multiple sequence alignment steps. Each of those will run sequentially. Those take a long time. So let's just say overall processing took 10 hours for AlphaFold 2. 9 hours of those would be actually running the multiple sequence alignment step. The last hour would be running on the GPU. So that's if you run the DeepMind's workflow, the original workflow. But we've got a way to divide that into 2 jobs, one CPU job, and then when that's done, you can run the second part on a GPU job, so you're not tying up a GPU for 9 hours without being used. A reminder that most of our compute nodes have 2 or more GPUs. So if you're running an AlphaFold job, you'll want to request just one GPU, but you don't request all the cores in memory. Most likely you won't need all the cores in memory. You cut it down to half the cores in memory, and the reason for that is if you request all the cores in memory on a compute node and only one of the GPUs, then the other GPU cannot be scheduled for another job. So we ask that when you're running AlphaFold, at least start with half the cores in memory. You can look at the resource usage afterwards and maybe go down to a fourth of the cores in memory. There's quite a bit of memory cores on ACES compute nodes. All right, so we use ParaFold to run AlphaFold 2 on ACES. ParaFold uses AlphaFold 2 code. It's in a repository called ParallelFold. ParallelFold started out, at least when I was looking back at it, that they were trying to design a workflow that would allow the first 4 multiple sequence alignment steps to run in parallel, and then that would help speed it up instead of running them sequentially. Eventually, it got to where they just divided up the 2 steps, the CPU step and the GPU step, in the 2 separate jobs, and that will save a lot of GPU idle time. The standard workflow was, again, you would tie up a GPU node for 10 hours, and 9 of those hours the GPU would be idle. And then AlphaFold 2 and ParaFold, they both run the 4 steps sequentially, but not in parallel. But AlphaFold 3, when they developed AlphaFold 3, they learned from the community that that's not the best approach. So they designed it to run to divide the processing into two jobs, and also run the 4 sequence alignment steps in parallel. So we have some shared databases on ACES for AlphaFold 232. You can use these for AlphaFold 2. You can see it's almost 3 terabytes and 200,000 files. So it's the best to use these files instead of trying to download your own copy of the database. Some of these files are used for monomer analysis, some for multimer. ParaFold will handle which databases to configure whenever without all you have to do is specify whether it's a monomer or multimer. All right, so let's go ahead and get started running AlphaFold 2. We have a utility called GCATemplates. And what this is we have some template scripts. We don't have a lot for ACES. We have a lot for other clusters, but so what we'll do is we'll go back to the command line, and let's see if I can make this bigger. Okay. Control L, clear the screen, and then we'll make a directory called scratch /AF underscore demo. You can call it AF2 underscore demo. So let's make our directory and then go to that directory. So all right, and then just CD to that directory. So we have an empty directory to run this analysis. So the utility is called GCATemplates. So you just run GCATemplates on the command line, and then we have very few here. You can hit GCAT and hit tab. So what we're looking for is protein tools. You can type in S for search and then search for ParaFold. You can do a search, or I'm just going to go through the menus. Two for protein tools, protein structure prediction. We have ParaFold with AlphaFold 232. And then we have 3 options here: the monomer PTM reduced databases, and then multimer. So we're going to select the reduced DB one, so number 2. And then you can see the name of the script is run ParaFold using AlphaFold 232, monomer PTM model, and then the reduced database is the database preset. So you type in Y and to copy to your directory. And then there's a reminder that this is just a template script. You'll want to review the script. There may be some options the software has that are not in the script that you may want to add, or some in the script that you may want to remove or change. Especially the running times. These scripts were designed to run small input files and get completed rather quickly. So this one, here's an example of the script. So we have the SBatch parameters at the top. Right now it's set to the max time. I'm going to type in. Actually, the max time has changed to 3 days. It used to be 7, but now it's 3 for a CPU job. So then we've got module purge. This is just something we recommend to add before loading your modules. Sometimes users will load modules in their bash RC, and then when the job starts, it loads other modules, and then it loads the modules in the job script, and there's some conflict between the libraries and there's errors. So we just recommend putting module purge in there. And what we've got remember there's 4 there's 4 parallel multiple sequence alignment steps. So each of those steps we use about 6 to 8 cores. So I have 8 set here. What do I have here? Oh, sorry, this is AlphaFold. I'm thinking AlphaFold 2, 3. This is AlphaFold 2. So since they're run sequentially, we only need about 8 cores. All right, so then there's some comments in here describing what's going on. The commands takes a while to look at it to see what's going on. But basically, there's a run AlphaFold command, the database directory, the output directory, and then a lot of this these are in variables which you can easily change, so you don't have to change the longer command. So, for example, the protein input file. This is an example protein that we'll be running. The database will keep that the same. Max template date, that's just a way to reproduce your results. You can change that to today if you want each time, or you can set a specific date and leave it. And the model preset depends on what you're running. And then we'll run reduce DBs. And then the outputs, the protein base name is taken from the FASTA file. And then there's, you can see the first command is right here, run AlphaFold. So what this is, when we loaded the ParaFold module, it allows you to run AlphaFold, and then there's a flag that allows -F that says just do the multiple sequence alignments. Don't do the structure prediction step on the GPU. So we run the multiple sequence alignments first. The end part here, double ampersand, means if this first part completes successfully, then schedule a job to run the GPU part. And the GPU part, basically, it's you're loading the modules again, and then you run AlphaFold again. But this time you specify one of these options, maybe it's -G, specifies to run structure prediction part. All right, and then we have some acknowledgments. Please, if you use our resources in your publications, we have an acknowledgement page. This is on our research citations. So we're trying to keep a list of everyone that publishes using our resources. You can see we have some work to do, at least gathering these resources. We had a student that went back in 2021 and captured a lot of these from the web, but we still have some catching up to do and putting these on there. So if you have a publication, please let us know, send us the DOI, and we can add it to our list here. All right, so this AlphaFold 2, it takes about 30 minutes. So what we're going to do is we're going to run this. We have a utility called, let's come back here. I'm going to Q to quit. We have a utility called CPUL. And you can see how many compute nodes are available, non-GPU nodes. You can see there's only 2 nodes right now. So when we submit this, it's not going to start right away. We'll have to, we're going to view a job that's already completed. And that way I'll show you how you can view the output files. And then later on, when your job completes, you'll be able to view your own. The reason for that is because we do have a reservation for the AlphaFold 3. We do want AlphaFold 3 to complete, so that one only takes like 10 minutes. But this one, it can take up to 30 minutes, and we only have a few. All right, so let's just submit the job as it is. You don't have to make any changes to it, and it's not going to start right away, but we'll go ahead and view some output files. So SBatch. All right, job submitted. You can see your job. That's actually job 83, so that's this job here. It'll stay pending for a while, but it'll complete. Once it starts, it'll complete in about 30 minutes. So you can check this at any time and see any running jobs or pending jobs. Once it completes, it won't show up here anymore, and then you can go to the directory where it was and look at the output files. Actually, mine just started running. So I use ls-lsth that sorts the files and puts the newest files on top. So you can see I created this file at 1024. The standard out and standard error were created, and now there's the output directory was created. So one thing you can do is make sure the file is in your current directory, and then SBAUAT, and then RUN and hit tab, because there's a lot of dashes and dots in there. You just want to make sure you don't misspell that. So see if you have you don't want to submit it again, but do ls and make sure you have that file in there. If not, you can go through go back and run GCATemplates. So we've got several people. Yeah, let me go back. GCATemplates. So you run GCATemplates, and then it's a protein tool 2, and then this is predict protein structure 1. This is running AlphaFold using ParaFold. So there's only one option here. Now we want to select the reduced DB, so type in 2. And then it asks if you want to copy. This one you need to type in Y to copy. I'm not going to copy it again. If I did, it'll say there's already a copy. Do you want to override it? I don't want to override it. Okay.
Excuse me, can you hear me?
I'm sorry, can you repeat that?
Can you hear me?
Yes.
Yeah, so after I type 2, what I need to do, I'm kind of not follow with your operation. So after I type 2, now I'm already in this interface.
Okay,
Now
so
I
there's
have to enter
just type in 1 because there's only one option. Sometimes we have multiple tools for protein tools, but we have very
1 and then enter.
yes.
Okay.
Yeah, we only have one.
ParaFold. Yeah.
So in this case, there's 3 different scripts, or at least 3 different scripts. Each one has a different option. So we want to do the reduce DBs option. So then you type in number 2.
Then number 2. Okay.
And you reach the final
Type,
script,
yes.
and there's the name. You type Y to copy.
Okay. Be sure to do. Okay. Oh, now I have this file. Okay, thank you. Thank you so much.
Okay. And then after you do that, you'll want to SBatch, type in RU and hit tab. Tab will fill in the name for you. So your history's saved, so I'm going to go up and see. Oh, I didn't think we'd have these running, but that's pretty good. So these are running on nodes without the reservation, so which is pretty good. All right, so that's going to take the multiple sequence alignment step takes about 25 minutes, and then the GPU part takes about 5 minutes. So you can see it's running as on a CPU node right now. All right, we'll let that run, and we'll come back to that. We're going to use the Files app to review a job that's already completed. So the Files app is on the portal. You click Files and then go to Scratch. And this is this utility. You can use it for editing files, copying. You can upload or download files here. Create new directories. Basically what you can do on the command line, they have functions for that. Create a new file, copy, move, delete a file. So we want to go to, this is a completed job there. This is a predicted LDDT scores. So here's the scale here. So greater than 90% is very high confidence. So you can see a dark blue is high confidence in the prediction. This is across the residues here. This is starting at the first one, and you can see all the scores, or there's only one score below 90. That's at the end, and that's probably because there's not much structure, or not, can't really tell past the end if it's really confident. But towards the middle part, which is the main part where the folds are, that is very high confidence. Most of it's over 92, 93. So here's the path for where we can view this file. So Scratch, Training, ParaFold. So you can click Scratch right here, and then come down to Training, and ParaFold. Scratch, Training, ParaFold. You can see the path is building here. And then out 1L2Y, out 1L2Y. And there's only one directory there. So when you go in here, these are the output files. There are 5 different models that are used, and they are ranked from, actually the ranking starts at 0. So 0 is the top ranked model. 1, 2, 3, 4. This is based on score. I'll show you that in a little bit. So let's look for ranked 0 PLDDT PNG. Rank 0 PL, this one right here. So you can click these 3 bars here and click view. You can view any of these files, but we're going to look at the PNG image. So Scratch, Training, ParaFold, out 1L2Y, and then this is a directory that AlphaFold created, and then view. See view, and you can see this is the predicted LDDT scores. Now this was run with reduced databases. I'll go over that. I have a slide to talk about that a little bit. So let's just give a thumbs up in the chat if you were able to navigate to this directory and view the output. So this is how you want to view the images, at least the images, the metric images. The actual protein fold PDB file, we'll look at that using a different utility. Because if you open this right now, if you open ranked 0 PDB, if you open it, it's just going to show you the protein database format. We want to see the actual fold. All right. So that's how you can view at least the metrics. In order to view the image on the right, we'll go over that in a little bit. There's some other metrics here. These are ranked PAE, predicted alignment error. This, you might find this useful, and we had some users who were interested in this. You can see here it is here, ranked 0 PAE, PNG. All right, model scores. There's a file with scores in there. You don't really have to look here to select or to view the top ranked. But you can look in this ranking debug.json. So ranking debug, this one right here. You can look at this file and you can see the scores here. It's like Model 2, and this run Model 2 had the highest score. So if you look at the order here, remember we looked at rank 0 PNG as that was the highest ranking. That's the score of the highest model. The Model 2 is rank 0 based on the score here. So if you're interested in looking at the overall score, you can look in this file. I just remember that the ranked, in order to see ranked, which model is ranked 0, you'll need to look at this order here. All right, so I did some benchmarking using running ParaFold, comparing it to the DeepMind processing. So ParaFold uses the same AlphaFold 2 code. ParaFold, as you see, we can run the CPU processing step first. That way we're not holding a GPU idle for the entire time, and then we can run the GPU processing. AlphaFold DeepMind workflow is different, where you actually run everything on a GPU node, and the GPU is idle for 90% of the processing. So this is a test run with full databases. The run times they vary. You're not going to always get 3 hours and 10 minutes running ParaFold. Sometimes it's more or less. So these are really, this doesn't mean that ParaFold is going to be quicker than DeepMind. It's just that this is the overall combined time of the CPU 3-hour job and a 10-minute GPU job. So this just means that if I was to run this again, the run times might be reversed. DeepMind might run longer. So you can see the scores are very similar, and even then, if running this again, these DeepMind might have a higher score, but they're very, very close. So the main point to take away from here is that relatively the same amount of time, same scores, basically using the same code, and you're just freeing up, you're not tying up a GPU while the multiple sequence alignment step is running. Okay, there's a software module called AlphaPickle. This was requested by one of our users that wanted to see a lot of these images, confidence metric images. You can add this into your scripts. I think we have this. Let's see. It's actually not in this script here. Actually, it is. It runs. AlphaPickle's run on the GPU part after the GPU part is run. So you can see we're loading AlphaPickle here. Remember, this is the second step, the GPU step. So during the GPU step, we load AlphaPickle, and then this will create images for the output directory after the structure prediction is complete. And if you did run AlphaFold 2 and you wanted to run AlphaPickle afterwards, you can do that if you didn't add it in your code. So this is just another comparison of the run times, and also another thing to take into consideration is the number of service units that you're charged. So we do add extra service unit charge for running on a GPU. So if you look at the graph on the left, this is AlphaFold. It is 231, but what we see here is this is one job, 90%. This is the usage on the GPU. So the percent load of the GPU, and then the amount of memory on the GPU. So you can see over 9.5 hours, the GPU wasn't being used. And finally, the last 15 minutes, there's some GPU activity. Both the load went up to almost 100 for a little bit, and then there was some memory usage here that may not have gone. You can see this is a A100 GPU on a different cluster, but this GPU has a 40 gigabytes of memory available. Only maybe 5 gigabytes was used. So basically you can see the GPU is idle for over 9 hours. And it's even if you're not using the GPU, but you have it in your job, reserved in your job, you'll still be charged service units. So this job was charged 1639 service units. ParaFold job, this is the GPU job. I don't have the graph for the CPU here, but basically the CPU part took 7.5 hours. Here's the GPU part. Again, we see the percent load in red, gigabytes of memory, max of 40 on this GPU is the same A100. And you can actually see it. It only took like 12.5 minutes. Here's actually runtime 13, 15, 14 minutes. And so you can see there's some spikes of GPU activity. But it only costs 226 service units. This is the CPU part and the GPU job. So it really helps to break this, to use the ParaFold workflow, both in terms of not having idle GPUs and also to save service units. All right, reduced databases. We're running our jobs of reduced databases. Still a lot of jobs running. ParaFold, you can specify reduced databases. Some users will run a lot of amino acid different sequences using reduced databases, and then maybe make some selection before running the full databases. It does complete a lot quicker, but with lower accuracy. So you have to decide before using reduced databases how you're going to interpret the results, and you're actually going to get the best results using the full databases, but it does take longer. And the difference is the small databases, it uses a subset of BFD, and this, from documentation, it takes the first non-consensus sequence of every cluster in this BFD database. So if you wanted to use this template script, make sure you remember that to change the database preset if you want to use the full databases. All right, so now we're going to run AlphaFold 3. Does anyone have any questions about AlphaFold 2? I'm actually going to cover a slide about the main difference, some of the difference between AlphaFold 2 and 3. I think it's the next one coming up. So this is the agreement form, or part of it. Terms of use, you'll want to just remember there's a couple of things here. Not publish the model parameters file. Also, there's something else in here about you must not use AlphaFold 3 output to train machine learning models or related technology. So you'll definitely want to read that and make sure that whatever you publish is not breaking their terms of service or terms of use. So this file, when you receive, you'll get it, fill out the form, and then they'll send you a link to download it. I think the link expires in 7 days. So you download it. Once you've got it, the file itself is good for your use after 7 days. It's just that the link they send you expires in 7 days. So once you have that downloaded, you can save it to your Scratch directory. So AlphaFold 2 versus AlphaFold 3, this is from the AlphaFold 3 abstract. One of the main differences is that AlphaFold 3 allows you to compare other interactions like protein ligand interactions And it has higher accuracy. You may still want to use AlphaFold multimer. You can always run each of those and just test the output if you have any doubt about which one to use. And of course, you'll want to cite the AlphaFold 3 paper if you use AlphaFold 3 in your research. All right, to run AlphaFold 3, first, let's just see a thumbs up of everyone who was able to get the af3.bin.zst file. This is the model parameters file. I see one person. Okay, you can definitely set this up, and then when you get your model parameters file, you can save it to your Scratch directory, and then you can run this at a later time. See how it works. So AlphaFold 3 uses a different type of input format. It's called JSON, and it's not the regular fast input. JSON has other information you can add, like for protein interactions or ligand interactions. You add those in that file, so you have more than just the FASTA sequence. So our AlphaFold 3 is based on a singularity image. It uses AlphaFold 3 version 3.0.1. So let's make a directory for AlphaFold 3 and go to that directory. So you can leave this, you don't, if you can decompress this, but it doesn't, you don't need to. AlphaFold 3 will run whether it's compressed or decompressed. So I would just leave it compressed just to save disk space. All right. So we have a utility called AlphaFold 3 job script, and this will create a job script for you. Instead of running GCATemplates, it'll help add a few more configurations in there, like the link to your parameters file and also the input file. We're also going to use a reservation to run this. So we'll use a different, we'll add a reservation parameter in there, so Slurm will use the reserved nodes. All right. So the script that gets generated, what it does is it runs the 4 multiple sequence alignment steps in parallel. That is actually controlled by AlphaFold 3 code, but we reserve enough cores, 4 cores for each step, 4 steps. So the job script is configured with 16 cores. And then once that first part is complete successfully, it will run the prediction step in a GPU job. The GPU job gets launched from the CPU job once the GPU job once the CPU job has completed successfully. If the CPU job runs out of memory or runs out of time, the GPU job doesn't get submitted because it has a dependency that the CPU job has to complete successfully. So the name of the script is AlphaFold 3 job script. If you just type in alpha and hit tab, then -H, you can see the help. I'm gonna hit Control L to clear. All right, so you can see that how to use this. You do need to give it a input file and a model directory. Not the file itself, but the directory where your model is. There are some default values like the max template date. You can change it here, or you can edit your job script afterwards. Number of recycles, default's 3. In the past, some users would want to use more recycles, although AlphaFold had recommended setting 3. But some people may want to experiment with more recycles. The output directory, you can change that. Otherwise, it will be in the same directory as this job script, and then it will append the job name and the job ID, and then the GPU type. If you don't select the GPU type, then it will be the first available. GPU, we have a utility called GPU veil. Type that. So we do have, make this a little bit smaller. So you can see this is the configuration. We have 16 nodes. Each of those nodes have 4 PVC GPUs. These are the Intel GPUs. So AlphaFold does not support running on these, unfortunately. You can see we have a lot of those available. But the nodes, AlphaFold does support running on the H100s and the A30s. As you can see, we have 3 nodes that have 4 H100s attached. We have 2 nodes that have 8 H100s attached. We only have 1 node that has 2 A30s. Oh, we have another node here that has 2 H100s. And then this is bottom part is basically what's available right now for jobs. You can see all the H100s are either being used for jobs or they're reserved. There's a A30 available. This is in the GPU debug partition. That partition, you type in sinfo, GPU debug has a 2-hour limit. GPU actually has a 2-day limit. So I'm not sure how that's going to work. They both have, if they're in their separate. Oh, you can specify. You need to specify the queue type if you're using GPU debug. The partition type, not the queue type, partition type. But we have reserved nodes for this job. So here is the input file, scratch data bio AlphaFold 3 examples. Okay, we've got 2 files there. We want to use the 2PV7. So 2, that's the file we want to use. So if you want to type that out so you have that path and you can copy and paste it, it'll be easier. Copy and paste and try to type it in later. See, we don't have anything yet. We're about to create the job script. All right, so the command is AlphaFold3 job script, the JSON path. This is the path we're going to use. So if you double click this, you see that little copy icon pop up. That means it's in my clipboard. I can hit right click and it will paste. I think you can also right click paste. Okay. I don't know if you can use Control V. Yep, you can use Control V also. And then your model directory. And for the model directory, we'll you can see I have my AlphaFold 3. That's my copy. All right. So there's the JSON input file we'll use. So go ahead and run. Don't hit enter yet. We want to add one more thing, but AlphaFold3 job script. And then -- JSON _ path. And then copy that and paste it with right click. And then do model dir. And then just for this course right now, we're going to use a reservation. It's only good for today. So if you're running this later or you're watching this recording later, you don't want to add this next step. But just for the people in the course today. Reservation, training, and then hit enter. All right, so it created a job script for us, and you can see it there. So we'll give you just a minute to type this in and get your job script. Just give us a thumbs up once you get your job script copy, and we're going to review it before submitting it. Looks like that. The other jobs. Oh, the CPU step completed. There's a GPU step now. There's. Yeah, the ParaFold job is the GPU step is pending. Okay, so another thumbs up if you have your job script, AlphaFold 3 job script. I see one person. Okay, that you'll need if you, that's so that's the file you download after filling out the form, the Google form, and then you'll need to save it in your Scratch directory. If you don't have it yet, then you can just keep the script like it is, and once you get your file, your af3.bin.zst file, you can save it to your Scratch, and then you can run this script. So go ahead and create the script at least. Oh, I guess you can't create it if you don't have it. You'll have the command saved in your history. So just when you do get your script, you can you can go up arrow. Yes, the link to the form is in the slides right here on slide 27. So once you get that file, you can follow along either using the slides or the recording. I think we do have another AlphaFold 3 recorded available. And we'll just look. So we do have, oh, actually fall of last year. It won't have. We didn't have AlphaFold 3 fall of 2024. It was the beginning of this year. So actually AlphaFold 3 will not be on this one. So you can follow along with the slides. All right. Just remember, don't put later on, don't put reservation in there. Actually, that's not on the slides. Okay. So now let's review the job script. So it's scheduled for 1 day. Remember, there's a max. I'm gonna queue to quit. For CPU jobs, it's a max of 3 days. So you could change this, and you may need to for your jobs. It may take 2 days. I don't know, but you can go ahead and request 3 days to make sure you don't run out of time. You see, we have there's 4 processes. Each of those can use 6 or 8 cores. So we'll request enough cores to cover all the parallel steps, all 4 of the parallel steps. AlphaFold recommends 64 gigabytes of memory, 128 for larger amino acids. So we're just going to set this to 164. I mean to 64. And then there's a module AlphaFold. You don't have to load this module to run it. This is just a way that we're able to see how many people are using AlphaFold. So you can keep everything like it is. When you do have an input file, you'll just need to change these two variables here, the directory and the file name, instead of using what we have as the example. Here's the model parameters directory. The code is in this directory, the database here. If we have a newer database, you can change this version. And then we only have one image here, so you can keep the image like it is. If you want to change recycles, max input date, you can do that. Output files, you can see the command is a little bit longer. Basically, you run a singularity command up to this point here, and up to this point right here. This is the first command. Singularity has all the input options here. If this command completes successfully, then it will start to run the second job. The second job is a GPU job. Basically, this whole part down here is a GPU job. You can see, got that set up for you. And there's a citation again. And then this is kind of the expected output, what you'll see. Of course, the names will be a little bit different. The name of this amino acid is 2PV7, but you'll look for, this is the file you want to load into an image viewer so you can see the structure. And there's some ranking scores and some other confidence scores. So we'll go over that once it's complete. So you can see it put the reservation in here for us. If you're going to run this same script later with your jobs, with your input files, make sure you remove this reserve equals training, reservation equals training, and also from up here remove those queue to quit, and then submit that. All right. This is AlphaFold 3 right here. It's pending. But if I hit up arrow and hit it again, it's already running again, running now, because we're running it on the reserve node. So got a few people running AlphaFold 3. All right, so while that's running, it's rather quick. We'll cover a few things. Here's an example of an input file. You can go look at this link, and it will show you other more detailed examples. Basically, what this is a multimer, or it's a dimer. Part A and B are the same sequence. If this just said A, then it would be a monomer sequence. But we've got two parts here, A and B, and each are the same. Version 1, this is not the version of AlphaFold, this is the version of the JSON format. I'm not sure, there might be version 2, but actually you'll just have to look and look at the input and make sure you follow this guideline here. Make sure you have this type of format. All right, so let's look at some of these cluster utilities. And so this helps you familiarize yourself with with the cluster. All right, with any of these, you can run these on the command line. Some of these are available on the portal. With any of these tools, you just run the command -h or --help, and it will show you how to use it. First one is my job. Let's see. My job. This will basically show you your job. Let's see. So my job, the one that's running, is this one. So it shows it's running, shows you which node it's running on, AC compute nodes 006. Reserved 32 cores here. And then it's still running, so you're not going to see efficiency right now until the job is complete. So if you use the -S flag, this actually will print out the first part we saw, but it'll also print out a copy of your job script. So if you lose your job script, there's a copy in the Slurm database. You can get that back like that. So that's with the -S. -H. You can also do other things like show quotas. If your quota is getting full, you can use a -D. It will show you which directory in your home directory. Let's see. So it shows this Mozilla directory. Well, it has 2,000 files in it. And then it'll show you the submit directory and the job, the line you use to submit. This is helpful to see what you did, because you may forget a week or two or a month later. It also shows you it's not here yet, but it'll show you the total time it took to run, which can be useful. And see, am I still running? All right, that's my job. You can see there's an example I put. It shows you the job wall clock time. That is actual run time. It took 7 minutes, 37 seconds to run this job. This is AlphaFold 3 demo. This is a previous job. So, all right. Here's another one. If your job is pending for a long time, we do have maintenance. It goes on a few times a year, and if the maintenance starts in, for example, right here, you may have scheduled a job for 24 hours, but the maintenance begins in 22 hours, so your job will remain pending because the maintenance starts before your job would complete if it started right now. So it'll remain pending. You don't have to cancel the job and submit it after the maintenance. It will remain in queue. Just keep your job in queue if you want to run after the maintenance. But if you think it'll complete within 22 hours, then you can cancel this job, reconfigure the JavaScript to use maybe 22 hours, because you got a 49-minute buffer there. So configure it to run 22 hours and see if it launches so it can complete before the maintenance begins. Maintenance, you can also run on the command line, and it will show you there's no ACES maintenance scheduled. If there's one scheduled, it'll give you the hours and minutes. It'll give me the days, I think, days, hours, and minutes until it starts. So you can configure your JavaScript based on the maintenance schedule if you need it. Max config. So this will allow you to see how many cores and how much memory is on a compute node. If you just run max config, it will run, it will display the CPU partition. Control L to clear and enter. All right, so it shows you all the partitions here, and the GPUs configured. It doesn't show you how many of each node, but there are at least one node that has two 830s attached. This also is a breakdown of how much a job using all the cores and all the memory for the maximum time, 3 days. So using a complete compute node for 3 days will cost 6,912 service units. Now, once you submit this, you'll be charged 6,912. If your job completes in 1 day, you'll be reimbursed 2/3 of this service units back. That usually takes just a few minutes. There is an extra charge for the GPUs, which I mentioned earlier. So if you wanted to see the maximum config for H100, we'll just do H100. This is actually going to show you, we actually have 8 H100s attached on this compute node. So it puts the configuration in here for you. These GPU nodes still have 96 cores and 488 gigabytes of memory, but the partition time limit is 2 days instead of 3 days. So you can copy and paste this into your job script and update as needed. In this example, it's showing one GPU, one of H100 GPUs. And remember, if you use one, you don't want to use all the cores in memory. So in this case, it scales the cores in memory down 1/8 because the biggest node has 8 GPUs. If you think you need more than this, you can increase this to half. This is an eighth, or a fourth would be 24, and on 22, increase that. Just be aware of, again, don't use all the cores in memory if you don't only using one GPU. Yeah, one question in the chat. Yes, the af3.bin file is, if you just copy it to your Scratch directory, that way you know where it is for any of your job scripts. You don't want, if you copy it into one of your working directories, then when you start a new directory, a new working directory, you'll have to remember which directory you saved it in. So it's easier just to save it in your Scratch directory. All right, GPUval. We looked at this, but I just want to show you these are also available on portal page. Let's go back here. Utilities, GPUval. You can see this is the output, basically the output from the command line. You see the similar, lots of PVCs available. But again, AlphaFold doesn't support running on PVCs. But that's very useful if your job is pending and you're wondering why H100s are in high demand. But sometimes you can see there might be one available, at least for A30. You can configure your AlphaFold 3 job script to run. You'll just need to specify a partition GPU debug, and that has a max of 2 hours. So it may complete within 2 hours. At least the job we're running now, the GPU part only takes like 2 minutes. That's because it's a short GPU, a short amino acid, and it's already in the database. But if you run it for, if you schedule it for 2 hours and it doesn't complete in 2 hours, you'll see the error message that it reached the max time limit, and you'll know that the job didn't complete processing, and you'll need to you'll run it again on something other than the GPU debug queue or partition. All right, CPUval, we saw that one. Sometimes there's very few available. So if you wanted to start a job right now and you could get by with 2 CPUs and 104 gigabytes of memory, you could configure probably not an AlphaFold job, but something else. You could most likely use the other resources on this compute node. This is the maintenance script. That's not on the portal. You have to run that on the command line. All right. So let's look at AlphaFold 3 results. I think our job's complete. Yeah, these are my, gee, that's the ParaFold job that's still pending. These are jobs I had running before I started, so you can see the GPU job is complete. If I was to do my job on this number, shows it completed. CPU efficiency was 12% for the 10 minutes. Used 9 gigabytes of memory. And then there's actually, since this was actually submitted from within a job script, so you can see here's the submit line. So Here are some confidence metrics in this file, model.cif. That is the structure we can view. And here's the documentation about what's in the output, more details. So let's go back to the portal. And we're going to go to interactive apps. We're going to say Jmol. Okay. So I actually got a newer version here. A bit newer. Okay, so this is a open source viewer. Basically, it's just a viewer. You can change how the format of how it's presented, but there's no analysis done here. It's just a viewer. So we're going to select 1 hour. Let's go ahead and make it 2. And number of cores 1, max 5. You can leave that there. You can put a file here, but we'll wait. But let's go down to advanced params and then select training for the reservation. So remember, let's see. There's not a lot of CPU nodes available, but we have some CPU nodes reserved. So put that at the bottom. So select advanced params training, 2 hours, 1 core 5. That's all that's really needed to view. You can click launch. So this is the job ID right here. You can see the job ID we have here. Here's the job ID was appended. So actually, we're already up to 1,273,812. It's good to append the job ID to output files so you'll know where this file, what job generated what file. That's done in the SBatch. That's done right here. The output file it's called standard out dot %x. That takes the name, so you can see standard out AlphaFold 3 GPUs. The name is appended, and since you don't know the job ID until the job is actually scheduled, you just use %j, and then it will append the job ID on the output file. All right, so what we're going to do is we can actually go to our directory. This is just an example, but you can go to your directory. So once this starts, launch Jmol, and then so about this session, you can see the time remaining. Once you're done, go ahead and click delete, and that will free up the resources for other jobs. You can increase the image quality here before you launch it. If you have any problems, the session ID, click this session ID, and then there is an output log. This is basically log file of the session. You might find some error messages in here towards the bottom. A lot of this is about Fluxbox. We're going to change this to move away from Fluxbox, so you won't see all of this screen and an invalid key. But you'll want to check here for any job you're running on the portal. If you have any issues, you check this session ID and then output log. Because if you ask us request some help, then we'll also check that output log. So once you have that open, open, then we want to go to, I'm already in Scratch. So AlphaFold 3 demo. Then we're going to go to output. And then the one with the longer name, that's the completed part job. And then look for this right there, the model.cif. So it's your Scratch directory, AF3 demo, output, and then the longer directory name to PV7, and then select model CIF and open. All right, you make this max it out. I'm hitting control, holding down control and using the mouse, scroll in and out, and then let go of control, and you can use the mouse to move it around in view. You see it's symmetrical here, since this is the same sequence twice, a dimer. You can see pretty symmetrical here. All right, so that's how you can view it. You can explore here. There's different ways to change the display. There's no processing here. It's basically just a viewer. But that may be what you need. Let's see. Chimera X is another utility you can use. Chimera X it has a lot more features. You can view in Chimera X, and you can if there's any predicted structures and in protein data bank, then you can also load those predictions and compare them to your prediction. A lot more features here for Chimera X. So you can use either one. Okay, so when you're done here, actually, if you're working on this, any portal job, this is still running in the background. It's actually connected to a login node. The login node is AC005. I'm sorry, not login node. It's actually running on a compute node. The compute node is named AC005. You can close this browser and go to a different computer, log in, and come back to this session, and then you can connect to your session. It's still running. So once you're done, just click delete and click OK, and that will remove your sessions. Now, if you wanted to see if you ran some sessions, if you wanted to see your last sessions, you could go to Jmol, and then down here at the bottom, the data root directory. So this will show you all of your in the output directory. This will show you all of your Jmol sessions. Click here till the arrow points down. This sorts it from the newest. So you can see I ran Jmol back February 2024. This is the one I just ran a few minutes ago. If you click here, you can still access the output file to check for any errors. You can see the job. I canceled the job. So, all right. So a lot of definitely all the human monomers have been predicted. I don't know what the status of them of all the human proteins. I think all the human proteins and mouse proteins have a prediction in this database here. When I did this class a couple of years ago, this 200 million protein was only like 900,000 proteins. 900,000, this wasn't even 1 million a few years ago, but you can see there's even a lot more predictions available. So if you know a protein, there might already be a prediction available. You can search it here and see it. There's also useful information in the FAQs. It shows how this database was generated and what went into all of the predictions in this database. So I found that to be useful. And then here's a list of references for AlphaFold 3 at the top. The next two are for AlphaFold 2. And here's the one for ParaFold. And then AlphaPickle if you use that one. So we have our documentation here in KB, TAMU, HPRC.edu.kb. So if you go to our main web page, you can just click this W here. Probably should be a K, huh? KB, and then you can search AlphaFold, AlphaFold, and then we have some examples. Basically what we went over today, the AlphaFold 3 JavaScript, and then some AlphaFold 2 examples, ParaFold, and then here's some other questions and answers that users have asked. All right. We have a user guide also, and if you have any questions, you could send us a email to our help desk, and then each email we receive gets a ticket generated, and one of our HPRC staff will take the ticket and work on it. And then once your issue's been resolved, found a solution, then let us know, and then we'll close the ticket. And that's pretty much it. If you have any questions, I'll hang around for a little bit. We have a survey here. You can click this link, or you can scan this QR code and let us know about the short course. Maybe you want to see more added to it. Maybe you're interested in different type of short course that might be helpful. So we'll keep the session open for, I guess, till just for a little bit longer. Once you apply, it takes about a business day or two to get the file. Once you apply for the AlphaFold 3 model parameters file.
Hey, so I got a question.
Sure.
So I used to use Rosetta a lot, mainly through like PyRosetta, which was super useful because I could like call it like a regular Python library and go, hey, fold this protein for me, or what's my delta delta G's of this protein? Is there any way to do something similar with AlphaFold?
What is the when you run PyRosetta, so you have a Python script that you write yourself?
Yeah, so it's whatever. So I do a whole bunch of stuff with this given protein. It's a custom Python script, right? But as part of it, I'm just calling PyRosetta as a library to say, hey, go deal with the folding and energetic calculations for me, and then come back and give me the PDB, and then I do a bunch of other stuff.
Mm-hmm.
It would be really awesome if I could just like switch in, AlphaFold instead.
I guess you could. I mean, basically just load the module and run it as a job script. I don't know if
Okay.
that's how you were doing your Python script.
Yeah, no, I guess it's a few more steps though, but I mean, I
Yeah.
guess I could. Um, And also follow-up question, if say I was going to do something stupid, like maybe have an amino acid sequence that I wanted to get a structure for, and then I wanted to change it by like one amino acid and get a structure for that, is there any way to circumvent like all of this realigning and stuff like that? Is there a way I can like shortchange that if I'm just doing like, one-off point mutations?
I think with AlphaFold 2, there is a way to specify before you run it, to specify the multiple sequence alignment directory, MSA directory. And that way it does run the alignments again. You can look into that. I don't know about AlphaFold 3. It might have a similar option, but I do remember that for AlphaFold 2.
Okay, cool, because yeah, that would make things go much faster on my end.
Yeah, I know that option's there for AlphaFold 2.
Okay. No, and at the start of this, you said that like, well, 90% of it runs on CPUs. I have a little Dell PowerEdge, but it doesn't have any GPUs on it. Like, how slow are we really talking if I try to make the whole thing run on a CPU? Like that last 10%, is it just impossible? Should I not even bother trying to put this on my Dell PowerEdge or?
You can run AlphaFold 2 with
Okay,
no GPU, but AlphaFold 3 requires a GPU.
okay.
Yeah, it'll take a little bit longer. Actually, for some of these, I don't have it here, but I did compare running it on just CPU, and it does take So maybe 15 minutes, might be taking an hour on CPU, something like that.
Okay.
But at least for AlphaFold, it requires a GPU. AlphaFold 3
Okay.
requires a GPU.
Yeah.
But AlphaFold 2, if you were to submit your job, AlphaFold 2 job, it first looks for GPU. If it doesn't find it, it says falling back to CPU. But AlphaFold 3, it requires GPU, yeah.
Okay. Cool. Cool. But yeah, no, for the scale of stuff I'm looking for, like fast and dirty will run on my Power Edge. Maybe I will put AlphaFold on my machine. But no, this is super useful. So thank you so much.
You're welcome. AlphaFold 2, I believe, yeah, we have we have a Singularity image, and we also have the software module. So you could download the Singularity image that we have.
Good. Because no, that's I don't know. Because personally, I'm bad at that sort of stuff, and so that's what I want is somebody else who already figured out those things for me. So
Yeah, let me see. Oh, my session has been terminated. Oh, I don't have it here. I can add one here. We have it on our other clusters. I'll put a
oh yeah, don't trouble yourself if it's on something else.
if you want it, if you want the image, just send an email to our help desk and
Okay.
I'll send you a copy of our image.
Cool. That'd probably be pretty useful. But yeah, let me play with it some more before I push you out and make you do some more work. So,
Okay.
but yeah, I think I'm good. So thanks so much for running one of these.
All right, thanks for coming.
Hello, I have also a question. Is it possible to see a record of this workshop somewhere after?
Yes, we will post a recording. The slides are available right now. Courses, AlphaFold 2 here. By the time maybe later you look at this, it might be in this AlphaFold 2 section might be in the previous courses, so you may have to go here to see it. So view details, here is the PDFs from previous years. This year, let's see. So you can go to our YouTube channel. It's gonna take a couple of weeks before we get this recording on our YouTube channel. We do have two. This one doesn't have AlphaFold 3 on it because this is fall of last year, and now we didn't have AlphaFold 3 until January of this year. So
Okay.
you see spring, I'm sorry, when you see fall of 2025 on here, that'll be the one that'll be today's course.
Okay. Thank you.
You're welcome. And of course, don't forget to subscribe. All right, looks like there's no more questions, so we're going to go ahead and end for today. If you have any questions, you can contact our help desk. Send us an email. Thank you.